Hello, welcome back. So, in the previous lesson, we saw how to create a GPIO output driver from scratch, and we were able to use this driver to set the pin that the LED is connected to set it on and off. Okay, we're going to use these drivers to help us show the performance or show the various aspects of our operating system that we have developed. So perhaps we may want to test a thread by seeing if the thread is being executed simply by placing the code that toggles the LED inside that thread. And if the LED is not turning on, then the thread has a problem. So just bear with the process. There's a reason why we start in this way. So in this lesson, we're going to start off by creating a driver for the universal asynchronous receiver transmitter known as the UART. And this will allow us to be able to send messages or information, including debug information, to our serial port so that we can observe it. Okay, so that we can have, let's say, a piece of information from each thread that is executing, and we can know that, okay, the particular scheduler that we have decided to use, the operating system is working in that manner based on the debug information that we receive. You see how all of this works later, but let's go ahead and make a copy of this last project. I'll close everything we have over here. I'll say copy over here, right click, copy, and then paste over here. And then I'll call this number 1 UART driver. Okay, so let's expand. I'm going to click over here to expand, source folder here. I'm going to create a file known as uart.c, and it's in this file that we shall put the functions for initializing the UART peripheral, as well as a function that would allow us to transmit data using the UART. So I'll right click over here, I'll say new over here, and I'll come to file over here, and I'll give it a name. I'll say uart.c over here like this. And in the includes folder, I'll right click, I'll say new, I'll say file over here, I'll say uart.h. And I'm going to include the guard over here by saying if not defined, if and def underscore uart underscore h underscore. If not defined, we want to define it. Copy this. And then end if, like this. Okay, so in here I'm going to include our STM32 f4.h, or perhaps I could even include it in the .c file. So in the .c file, I'll include our .h by saying include over here, and then I'll simply say uart.h, and down here I'll say include. And what we want to include is our STM32F4XX.h, like this. Okay, so once that is done, we're going to have a function. In this in our application, we just need a UART to transmit data. We don't need it to receive data. So I'm going to come over here and create a function that will allow us to do that. So I'll say void over here, UART underscore TX for transmit in it. And then this function takes no argument. We open and we close. So before we go on to execute the function, let's list the tasks or the steps that we would have to take. So first of all, come over here, step by step. The first thing we'll do, remember, just like we did for the GPIO, each peripheral requires clock access. By default, the clock access is disabled. This is what is known as the clock gating mechanism. So before we use any peripheral, we have to enable clock access to that peripheral. So then this implies if we want to use the UART peripheral, we would have to enable clock access to the UART. But before even doing that, the UART is a peripheral, right? But the peripheral requires pins. Remember, UART has an RX line for receiving information and a TX line for transmitting information. These are GPIO pins. Okay, So these GPIO pins, we would have to configure them as well. So first, we would have to find the GPIO pins for the UART that we've chosen to use, and we would have to configure those GPIO pins to work in alternate function mode, because GPIO pins, they can work as either input, output, as analog pins, or as alternate function pins. And in the alternate function settings, they can be either a UART pin, an SPI pin, an I2C pin, etc. So we would have to configure it and say, okay, this pin, this time we want you to be working in your alternate function mode, and the alternate function we want you to assume is your UART function. So why am I saying all of this, and how do I know this? Well, let's find it out together. Like most things, or like everything, you find it in the documentation, one of the documents we've downloaded. We start off by taking a look at the block diagram that we saw earlier. It's page 15 over here. Let's see. Yeah, page 15. Okay, so we saw this block diagram, and we explained that these rectangles represent modules or peripherals. So we have USAT over here. We have USAT. This one here is called USAT 2. This one here is called USAT 6. This one here is called USAT 1. Okay, why is it written USAT here? USAT stands for Universal Synchronous Asynchronous Receiver Transmitter. However, because we often use just the asynchronous protocol of the synchronous asynchronous receiver transmitter, we often simply refer to it as UART without the S. So it's the same thing over here. The document is trying to tell you it works in both synchronous and asynchronous mode, but because we are interested in the asynchronous mode, we don't mention the S when we pronounce its name. Anyway, we've got a number of them here, right? And you'll see that by each UART module, we've got these notations, or these namings. We've got TX, RX as AF, and what this stands for is receiver transmitter as alternate function, and we have CTS, RTS as AF, right? So these 4 lines are pins, they are GPIO pins, and it's telling us that we would have to configure those GPIO pins as AF, meaning alternate function. Okay, we find that the USAT 1 has the same thing over here, and we have USAT 6 as well. Okay, now we would have to select one of the USAT modules or UART modules. So when I say UART, it means USAT, as I've explained. We would have to select one of them to use. So we're going to select USAT 2 over here. The reason we want to do that is because the RX and TX lines, or the pins for this USAT, are directly connected to the USB that we use to debug our microcontroller, the USB that we use to flash the code into the microcontroller and debug it as well. So because of that, when we use this, then the USB would be our physical connection between our 2 devices communicating using the UART protocol. The 2 devices is going to be our computer and then our Nucleo dev board. If we choose to use a separate module such as USAT 1, then we would have to connect an external USAT to USB converter between our computer and our development board. So because I don't want us to do that, then we are using this. However, if you are using the STM32 discovery board, you would have no choice but have that external USAT to USB converter, because the STM32 discovery board's USAT, none of the USAT is connected to the USB cable. Okay, so we are going to select USAT 2 over here. So let's see, USAT 2 is connected to the APB1 bus. So this implies that we would have to enable clock access to the APB1. We would have to enable clock access to the USAT 2 by going through the APB1 enable register. So we'll keep this in mind. Okay, so then let's find which pins are these RX and TX. To do that, in this same document, I'll come up here and then I'll do Ctrl F, and then I'll search alternate function. Okay, And it brings me over here. There's this table called table 9, and the table is called alternate function mapping. I'll click here. So this table tells us the alternate function of the pins in our microcontroller. In this first column, it's called the port, meaning the various ports. And then the second column is AF0, AF1, AF2, AF3, AF4, all the way to AF15. So we are in port A. PA0 here, when we set it to AF1, it becomes timer 2 channel 1. That's what this means. But we are looking for UART, RX, and TX. So let's see. We have PA2 here. So PA2, when we set it to alternate function 7, AF07, which is AF7, it gives us USAT TX line. So we found our first pin. So the TX line is PA2. And then we have PA3 here. PA3, when we set it to AF7, it gives us USAT2 RX line. So it's important to know that it's USAT2 we're dealing with. So USAT2 TX line for PA2, USAT2 RX line. So the pin, because we are making a TX, or we are developing a TX driver, we're interested in PA2. Okay, so we'll keep this in mind. So let's go and write what we've learned down. PA2 belongs to GPIO port A. So we need to enable clock access to GPIO port A and set PA2 to work in alternate function mode and set the alternate function type to AF7. Okay. So I'll come over here. I'll say enable clock access to GPIO A. Set PA2 mode to alternate function mode. And then once that is done, we're going to say over here, set alternate function type to AF7, which is UART. And this is, as we saw, this is UART2 TX line. Okay, so once that is done, we will be done with the pin of the UART configuration. Then we would go on to enable or configure the UART module itself. So what we will do is first enable clock access to the UART2, or USAT2 if you prefer that. Enable clock access to UART2. I wonder why my caps is locked. Once we've enabled clock access to UART2, we're going to configure the baud rate. The baud rate is going to be the communication speed. So I'll say configure over here, baud rate. And once we've configured baud rate, we would set the transfer direction, whether we want it to be TX, RX, or both. So we want to set the transfer direction here to TX. So I'll say over here, configure transfer direction. And once that is done, I'll come down here. We simply enable the UART module. Okay, so these are the steps required to configure our UART in TX mode, transmitter mode. So in the next lesson, we shall execute these steps, or we shall implement them. That's all there is. I'll see you. Have a nice day.